All right, guys, there's one other pressure one that deals with height, and then that was, we talked about it in the notes, what we call absolute pressure is going to equal to the atmosphere's pressure plus the density of the fluid times gravity times h, which is going to be the depth. So this is when the container's open to the atmosphere, which is the simulation here. Now, if it asks for gauge pressure, then, so P naught is the atmosphere, and it's 1.01. Sometimes I use 1, so if we're a little slightly off, I can't remember what I sometimes shortcut it, but it's 1 or 1.01. You will at least agree within reason of each other. That's P naught. Now, that's if it's open to the atmosphere. If it's a confined fluid, then if you want gauge, then P naught goes away to 0 pascals. So it depends. Just look at the situation. If it's an open body of water, or any fluid for that matter, if the container's open, then you need the atmosphere's pressure. If it's a closed container and it's asking for gauge pressure, then you just P naught goes away. The other situation for siphons. So it's not that P naught. If you're talking about a siphon, which I think is this next slide, what happens is, so to create a siphon, you got to lower the pressure inside, like the straw. How do straws work? You suck in air from the straw, which is why sometimes it makes you gassy. You're actually pulling in some air into your lungs, into your stomach. I mean, yeah, you're swallowing it, right? But that drops the pressure inside the straw, and then the atmosphere pushes the fluid up into the straw. If you have a sealed container with a straw and you can keep the atmosphere from getting in, it is impossible to suck out of. You'll just suck on it. The container might squeeze as air's trying to come in, but you won't get any fluid out of it. So siphon, what happens with a siphon? It is P equals P naught plus rho GH. But the pressure inside the tube is this question A. What is the smallest possible air pressure inside the tube? Well, if you want to create a siphon, you got to drop that pressure to 0. And then the atmosphere is still the 1.01 times 10 to the 5th. And then you can calculate what is the longest siphon you could create. Turns out it's around 30 feet. I don't know if you have what you have for a water supply, but if your home is on a well system and the well is less than 30 feet, then your pump is on the surface and creates a vacuum. Like you'll find it somewhere in your house or garage, but it would create that pump would siphon out the air, and then the atmosphere is actually pushing it up. As long as it's less than 30 feet. If it's more than 30 feet, like how do they get the water up into the water towers that you see all over Chesapeake? Those are larger than 30 feet. So you can't put the pump up in the tower. They put the pump at the ground, and then it actually pushes it up. But then that's not a siphon. It's literally pushing the water up into that tower. And then why do they do that? Sorry, I'm going on tangent here, but I think it's interesting. How do you get, when you turn on a faucet, there's pressure already there. You don't have to wait for a motor or a pump to kick on. Now, if you're on well water, then the pump to your home is pressurized. It's already at a high pressure. If you're hooked up to the city's water, they pump water up into those towers, and then that elevation of water creates a pressure difference, right? Height is based on pressure. Pressure is based on height. Sorry, the other way around. But so you always have pressure in your house as long as there's water in those towers. The alternative would be to have pumps either on you'd have to have it on every person's home, like always pressurizing the water, and then that would be a huge electrical drain, plus upkeep of the end motors and stuff like of the pumps. Like it's not that it can't be done, it's just not reasonable. So they have a couple pumps for each of the water towers, and then they just pump it up the water tower, and then they hook the lines to that tower to create that pressure that you get at your home. All right, done tormenting you.